Welcome to qnawire.
Alright, so for this one, we're going to need to look at hybridization of orbitals and a little bit of molecular geometry. So looking at our first example, we see we have a carbon with 4 chlorines. So since there's 4 chlorines around this carbon atom, it needs to be sp3 hybridized. That means we have 4 total orbitals. So we can draw this. We know that sp3 hybridized forms a tetrahedron, so it's not quite a square. And then we're going to have a chlorine on each of these. So since chlorine only forms one bond traditionally, it's going to have to be a terminal. Add in our lone pairs. And now we need to show the overlapping orbitals. So this chlorine is also going to be sp3 hybridized. It might be a little bit less obvious as to why. It looks like it only has one thing bound to it. It's only got this carbon here. But it also needs to put its lone electron pairs in orbitals of equal energy. And so if you count up the 3 pairs plus the 1 bond, we get to 4. So we're going to need to draw in, I'm going to use red, orbitals overlapping from each of these. And your drawings might be a little bit better than mine. But they should be roughly teardrop shaped. And then label them all sp3. Now for our next one, it's going to be very similar. We've got ammonia here. It is also going to be sp3, and the reason for that is it has 2 lone pairs in addition to the 3 hydrogens. So again, we have to add those together to get 4 total orbitals, and it's going to look something like this. Just draw the orbitals in from the beginning. So it's got 1 hydrogen in one orbital. It has a hydrogen in another orbital. 3 total hydrogens. And then it's got an sp2 orbital, or an sp3, orbital with just a lone electron pair in it. And the hydrogens, having only 2 electrons, don't have any extra lone electron pairs. For OF2, or fluorine oxide, we have our oxygen molecule. It likes to form 2 bonds. So I'm going to draw those here to our fluorine. I've drawn it as linear, but in reality it's not because it's 3-dimensional. So these aren't going to exist in the same plane. And again, oxygen has 2 bonds and 2 lone electron pairs. So this is also sp3. Make sure to label all the orbitals sp3. And for CO2 is where we finally depart from sp3 things, because carbon needs to form 4 bonds. So if we drew our traditional sort of Lewis structure, we see that we only have 2 bonds. So we're going to add in a second bond to each oxygen. That leaves it with no lone electron pairs. Since it only has 2 orbitals, you have s and 1 p in your hybrid. And the other 2 p orbitals aren't just missing, they are these the second bond in these double bonds. So don't forget the lone electron pairs on oxygen. I realized I forgot them on fluorine over here. Also shouldn't do that. And then you can draw in. So these black orbitals are the sp ones, and the red orbitals I'm going to draw here are the p. So carbon has a p, oxygen has a p, and they kind of overlap like this. And then there's another one. Second bond here. And our red, sort of to color code it, our red are the p orbitals.